Welcome back. You are with me, Madam Wan. Today, we are going to continue our lesson 5.2, which is trigonometric function. Are you ready? Let's do this. In this 5.2 subtopic, there are 5 learning outcomes that the students have to master. The first one is trigonometric ratios. The second one is the trigonometric ratios of an angle with its complementary angle. The third one is find the exact values of trigonometric functions for some special angles. The fourth one is determine trigonometric function for any angle. And the last one, to solve trigonometric function. Let's start with trigonometric ratio. What does it mean by that? It means that the ratio of every side of the right triangle. We have hypotenuse, opposite, and adjacent. An easy way to remember is so, ka, toa. Also bear in mind that there are formula that you have to memorize, which is cosecant theta equals to 1 over sine theta, secant theta equals to 1 over cos theta, tangent theta equals to sine theta over cos theta, while cotangent theta equals to 1 tangent theta or equals to cos theta over sine theta. Let's try example 1. Given that sine theta equals to 3 over 5 and theta is acute angle, find cos theta, tangent theta, cosecant, secant, and cotangent. So the first step, since it says that it is an acute angle, therefore the theta located at the first quadrant. And then so, opposite is 3. And hypotenuse is 5. By using theorem Pythagoras, we know that this is 4. Once we completed the sides, we can find all the things that the question wants. So cos theta equals to 4 over 5. Tangent theta equals to 3 over 4. Cosecant theta equals to 1 over sine theta. So it's a reverse, 5 over 3. And then secant theta equals to 1 over cos theta, 5 over 4, while cotangent theta is equals to 1 over tangent theta. So it's a reciprocal of 3 over 4, which is 4 over 3. Easy, right? Next, let's have a look at the relationship of the trigonometric ratio of an angle theta with its complementary angle. So if we look at here, the right triangle, we have 90 degree and then followed by theta, and this is we call the complementary angle. Okay? So if given that cos theta equals to x over z, cos, ka, adjacent over hypotenuse. Therefore, the angle that give x over z is we call the complementary angle. So sine is so opposite over hypotenuse. So same goes to the proof for other functions such as tangent is the complementary of cotangent theta, while cotangent theta is the complementary angle for tangent theta, while cosecant theta is the complementary angle for secant theta and the other way around. Okay. So for example, given that sine 55, since it is complement with cos 90, therefore we minus with 55, we will get cos 35. And the next one, for tangent theta, since the complementary angle is cotangent 90 minus with the angle 20, so we will get cotangent 70. And the last one, for example, secant 35, since the complementary angle is equals to cosecant 90 minus 35, the angle just now, therefore we will get cosecant 55. Let's move on quickly to 5.2c, where the learning outcome is trigonometric ratios of some special angles. So this angle, 45 degree, can be getting by the isosceles triangle, where it has two equal sides, while the 30 degree and 60 degree angles can be getting by equilateral triangle, where it has three equal sides that cut into two. Okay, and we can come out with this table, but you don't have to memorize this. Okay, let's go through example 2. Okay, show that 2 sine 30 plus cos 45 degree over tangent 45 is equals to, as stated in the right hand side. Okay, let's do this. Okay, 2 sine 30. Okay, what is sine 30 just now? Sine 30 is here, where the triangle is cut into two, which is 2, 1, and sec 3. Okay, so sine is so opposite over hypotenuse, 1 over 2. Okay, plus cos 45. Cos 45 is 1 over sec 2 over tangent 45. Okay, so tangent 45 is over 1. Okay, we don't need to write over 1. Okay, since the denominator is not the same, so we choose to multiply with sec 2 top and bottom, so that this right here will be coming 2. Okay, so 1 plus sec 2 over 2. Okay, and then 2 and 2 can be cancelled out. Will give us 1 plus sec 2. But we not yet get as the right hand side here. Okay, since the right hand side has sec 2 on the denominator, therefore we have to multiply with sec 2. Okay, multiply with sec 2 top and bottom. Okay, don't forget to write the bracket, and then we expand sec 2 plus sec 2. Sec 2 will give us 2 over sec 2. Now, it's already same as stated on the right hand side. Then we can proudly write down shown. Okay. Alright, let's move on. Example 3. Find the values of the following trigonometric function for some special angles. We will try to solve these two questions, yeah? So tangent, negative 120. So negative just show it's rotated clockwise or downward. Okay, so this is 90. So 120 is somewhere here. Okay, but bear in mind that we want acute angle that lies on the x. X axis here. Okay, we want this. Okay, so 180 degree minus with 120 will give us 60 degree. Okay, therefore, tangent negative 120 is equivalent to tangent 60 degree. And since tangent is positive at the third quadrant, so yeah, it's positive, so we don't need to write down. Okay, tangent 60. What is tangent 60? Tangent 60 is 60 is over here, and then tangent, it's from the so set 3. Okay. And then sine negative 135. Okay, sine negative 135 is at the third quadrant as well, because it's in between 90 to 180, yeah? So again, we want the acute angle. So we want here. So 180 minus 135 will give us 45. And this can be written as sine 45. But sine at the third quadrant is negative. Okay, so we have to write down negative here, okay? Okay, so sine 45. So this is 45 degree. So 1 set 2. So sine is so opposite over hypotenuse, 1 over sec 2. And we're done. Let's look at a trigonometric function for any angles. Okay, given sine 488, so it's greater than 360. So we can minus with 360 degree, 1 to 8. So 1 to 8 located at the second quadrant here, somewhere here. But it's rotated twice like that. Okay. So we can write down sine 488 is also equivalent to sine 1 to 8. Which when you press your calculator, because it is not special angle, so you press your calculator, it will give you 0.7880. Okay. Same goes to B. Tangent negative 174. 174. So here is negative 90, negative 174. Okay. Negative 174. So we want the acute angle here. So 180 minus 174 is 6 degree. Therefore, it can be written as tangent 6. Okay, tangent at the second quadrant is positive. So, you press your calculator, tangent 6 will give you 0.1051, which is equivalent to tangent negative 175. Okay? Okay. So I let you to try these two example yourself. Okay?